Hello and welcome back to Gaffy's Grinds. Stick your phone on silent, close any open tabs that you have, especially social media, and make sure you do the questions when I ask you. In today's video, we're going to be learning how to write the formula of ionic compounds. So in the previous video, we looked at how ions are formed from the different atoms of different elements in different groups of the periodic table. So we're just going to begin with a summary of that. So we're going to fill out this table. So I'm going to do the first one for you, group one. I'm going to show you how I want you to do it, and then I'm going to ask you to pause the video, and I'm going to ask you to do it for the rest of the groups. So let's look at group one. Group one, elements of group one all have one electron in their outer shell. So the outer electrons, I'm writing one. Okay, so remember, the group number means that's how many electrons they have in their outer shell. So group one have one electron in their outer shell. What will happen when they become an ion? Will they lose or gain electrons? Well, they will lose one electron. That's what happens to elements in group one. When they lose one electron, they then have a full outer shell. They lose that outer shell, and the next one is full. Charge on the ion, so if they've lost one electron, they will be a +1 ion, or 1+, probably a better way of saying it, 1+. 1+ ion. And examples. So to figure out the examples, I need to go to my periodic table, find out what elements are here. I know I've got lithium, Li+, I've got sodium, Na+, and I've got potassium, K+. All right, so that's how I want you to do it. What I want you to do is I want you to pause the video, draw the outline of the table, and take down what I have, and I want you to finish it for the rest of them. All right, this is what you should have. You should only be watching if you've paused the video and you've done this. If you haven't, then and you just copy what I'm writing, you're wasting your time. You're not actually going to learn anything. But this is what you should have. So obviously, group two, I'm just going to do all of the outer electrons first. Group two, they have 2 electrons in their outer shell. Group three have 3. Group 5 have 5. Group 6 have 6. And group 7 have 7. So the key thing there is whatever group they're in, that's the amount of electrons they've got in their outer shell. That's not new for us. What's going to happen? Group two, are they going to lose or gain electrons? Well, they're going to lose 2. It's closer and easier for them to lose 2 electrons. What about group 3? Well, again, this is closer to 1 or 0, if you like. So they are going to lose 3. What about group 5? Well, group 5 would like to have 8 in their outer shell. They've got 5 already, so they can lose 5 or gain 3. Gaining 3 is easier, so they're going to gain 3 electrons. Group 6 need to gain 2. And group 7 needs to gain 1. So they're going to gain 1. Well done. If you got all those right, good job. If not, fix them now. All right, you should have them 2 rows right. What charge will the ion take? Well, if group 2 are going to lose 2 electrons, lose 2 of their minuses, so that leaves them with a 2+ charge. Group 3 have lost 3 of their minuses, so that leaves them with a 3+ charge. Group 5, they have gained 3 extra minuses, 3 extra electrons. So they are going to be 3 minus. Group 6, 2 minus. Group 7, 1 minus. Like that. Okay, so again, well done if you got that right. If not, you need to fix it out. Examples then, well, group 2 are things like beryllium, Be2+, magnesium, Mg2+, and calcium, Ca2+. So again, go to periodic table, find examples. Group 3, we're talking about aluminium, Al3+. Group 5, we're talking about like phosphorus, P3-, or nitrogen 3-. We then have group 6, like oxygen 2-, or sulfur 2-. And then group 7, you have F-, Cl-, and Br-. And again, if you don't know what any of that is about, then you need to go back and watch the previous video. Otherwise, this video is going to be very difficult. All right, so looking at this row in particular, I'm just going to highlight this row in particular. Okay, we can sometimes put that onto a periodic table. You sometimes see diagrams like this one here. Now I just need to color something in for a second. I'm just going to get rid of this stuff here. Okay, so notice we are ignoring group number 4 for now. Group number 4 does not form any ions, that's why. Okay, so we're just going to leave that out of it, the conversation for a minute. But all we've done is we've taken this row from up here that I've highlighted, and we've brought it down and stuck it back on top of the periodic table, as you can see. Group 1 form +1 ions, group 2 form +2 ions, group 3 form +3 ions, group 5, which is nitrogen, they form -3 ions. Okay, so as you can see here, group 6, which is oxygen, form -2 ions, and group 7, fluorine, form -1 ions. So sometimes you will see a diagram like this, and it's sometimes a good way of thinking about it. If you can picture those numbers on top of the groups, And remember that we're forgetting about group 4 I will explain why later in another video, but for now, I'm just going to ask you to stick with me on that one. All right. So as you can see, the groups are down here, group 1 plus 1, group 2 plus 2, and so on. But it's not just kind of a learn off, there's the numbers, learn them off. I want you to understand why as well, which is why we've explained really carefully. Now, we're going to look at naming some compounds today, naming and writing the formulas of some ionic compounds. And there's one rule I need you guys to learn, and that is this rule. So there is a rule, and that rule says that ionic compounds, okay, so ionic compounds have a neutral charge. Ionic compounds have a neutral charge. And what does neutral mean? It means that neutral just means that the charge equals to 0. So overall, an ionic compound must have a charge equal to 0. Just actually going to fix that so it's a nice neat box. Okay, so that's a rule I need you guys to remember, that an ionic compound must have a charge equal to 0. All right, so again, what I'm going to ask you to do is I'm going to ask you to pause the video and take down that rule. Okay, so you should only be playing if you've taken down the rule in your notes copy, and let's have a look at some examples now. Let's say we have a compound and it's called lithium fluoride. Lithium and fluoride is made from mixing together lithium and fluorine. Okay, so how do we figure out what the formula is going to be? Well, the first thing we need to do is figure out what group each thing is in. Lithium is in group 1. G1 means group 1. Fluoride or fluorine is in group 7. So if lithium is in group 1, then we know that that means that it forms an Li plus 1 ion. So it forms an Li plus 1 ion. Fluoride, or the fluoride ion, it's in group 7, which means that it's going to form a minus 1 ion, like that. Okay, so lithium and fluorine minus 1. Lithium is plus 1 and fluorine is minus 1. So if I was to draw them out, I would get a lithium ion would look like this, Li plus, and the fluorine would look like this, so the fluoride ion would look like this, F minus 1. This is Li plus 1, and as you can see, together, to get them to have no charge overall, we need one of each. So we get the formula Li, 1 Li and 1 F, lithium fluoride. We put these two together, plus 1 and a minus 1, we get neutral 0. So the formula for this particular compound is LiF. Okay, let's have a look at another one. This one is called magnesium. Sorry, this has stopped working on me now. I have to pause the video for a second. Okay, and I'm back. So this second compound is called magnesium oxide. Magnesium oxide. Okay, so the first thing I'm going to do is I'm going to figure out which group these are in. Okay, so magnesium oxide. Well, the elements are magnesium. Magnesium is in group 2. Group 2. What does that mean? That means magnesium forms Mg2 plus ions. And oxide is in group 6. Group 6. Which means that it forms O2 minus ions. Okay, so if I was to draw these out, I would have an Mg2 plus and an O2 minus. Now, obviously, if you stick one of each of these together, it's an Mg2 plus and an O2 minus. Those balance each other out, those charges, to make 0. So that means I just need one of each. So that's going to give me the formula MgO. 1 magnesium and 1 oxygen. Right. you're going to do one now. So let's take the substance aluminium phosphide. Aluminium phosphide. Okay, so what I want you guys to do is I want you to pause the video and find out what the formula is going to be. Okay, so you should only be playing if you have figured out what the formula of aluminium phosphide is going to be. I'm going to begin by finding out what group each of them is in. So aluminium is in group 3, and phosphide ion comes from phosphorus. Phosphorus is in group 5. Now, if you didn't know that, you can pause the video and have another go. Try it now. Okay, so this is what you should be writing. Aluminium forms the Al3 plus ion, whereas phosphorus forms the P3 minus ion because it's in group 5. So if I was to draw the aluminium, it would look like this. I would get Al3 plus. And the phosphorus, I will get P3 minus. So if I've got a +3 charge and a -3 charge, they will cancel each other out, or they will balance to give me a neutral compound. So I just need one Al and one P. So AlP is the correct formula for aluminium phosphide. Right, you're ready to have a go at a few by yourself now. All right, so here in this table, what I want you to do for each one is I want you to fill in the blanks. So in the first one, you're going to need to write down, this is a substance with potassium and chlorine. So I need you to work the formula and then tell me what its name would be. For this one, I'm telling you the name and I need you to tell me what elements are in here, the 2 elements, and what the formula would be. Same for this one. So pause the video, fill out the table now. I need the answers where the X's are. Okay, so pause the video, do that now. All right, so what you should have got for the first one is you should have got KCl. That's the formula, 1K and 1Cl. And the substance name is potassium chloride. Potassium chloride. Sorry, squeeze it in there. Next one, potassium iodide. What elements? Well, I've got potassium, and iodide is going to be iodine, is the second element. Iodine, group 7 of the periodic table. So the formula is going to be Ki. All right, well done if you got that right. Last one, calcium oxide. The elements in here are calcium and oxygen. And that's going to give me the formula Ca for calcium. There's 1 Ca for 1 oxygen, because the Ca forms a 2+ and the oxygen forms an O2-, and these two cancel each other out, or they balance. So I just need one of each. Okay, so CaO is the correct answer. Well done, you got that right. Let's look at some that are a little bit harder now. So remember, we still have that same rule. The rule is that ionic compounds have a charge of 0, or have a neutral charge. That's the rule. Okay, so let's try one that's a little bit harder. Here, I've got sodium. Right, I've got the compound sodium oxide. Sodium oxide. Okay, let's start off by working out what group they're in. Sodium is in group 1. Oxygen is in group 6. So you can see here that it is actually a little bit more complicated. Okay, because sodium has the symbol Na and it's in group 1, it's going to form a +1 ion. Oxygen has the symbol O, but it's in group 6, so it's going to form a 2- ion. So if I was to draw this out, I would get Na+, and here I would get an O2-. Now, hopefully you can see that +1 and -2, or 2-, together, if we add these up, they give us -1. So I still have one extra minus. So what can I do to fix that? Well, what I can do is I can add in another of the sodiums. So like this, I'll get rid of these. I'm going to put another Na plus here. So all this is saying is that one oxygen bonds to or attracts to 2 sodiums. Okay, so 2 Na plus 1s balance out an O2 minus. So this gives me a compound with the formula Na2 down here, subscript shows the number of sodiums, Na2O, which is really an O1, but remember we don't need to write that one. So Na2O is the formula for this compound. Right, you're going to try this one. Magnesium Fluoride. Magnesium chloride. Right, pause the video to have a go and the answers will come up in a minute. Okay, the first thing we've got to do is find out what group they're in. So again, you should only be watching if you've got this done. Magnesium is group 2, chlorine or chloride ion is from group 7. Okay, so what does that mean? Well, it means that the magnesium forms the Mg plus 2 plus ion, Mg2 plus. Okay. Chlorine forms a Cl minus 1 ion, Cl minus 1. So again, if we were to draw these out, here I would have an Mg2 plus, like that. And over here, I would have a Cl minus. And again, if I was to add these up, I would get 2 plus with a -1 would still leave me with a charge of +1. And I can't have that because the rule is that ionic compounds, up here, the rule ionic compounds have a charge of 0. That's my rule that I have to stick to. Ionic compounds have a charge of 0. So down here, this isn't equaling 0. So how can I make it equal 0? It's pretty straightforward. I hope that you realize that if I add another chloride, now they add up to 0. Okay, so that gives me the formula Mg, there's one of them, Cl2, there's 2 of them, MgCl2. Right, you do this one as well, aluminium fluoride. Aluminium fluoride. All right, pause the video and do this one for me now. Okay, so you should only be watching if you've got aluminium fluoride done. Aluminium is a metal in group 3. Fluoride is a non-metal in group 7. It comes from the element fluorine. Okay, so what does this mean? Well, if it's in group 3, that means aluminium forms a 3 plus ion and fluorine forms a -1 ion. Okay, so Al 3 plus and F -1. All right, so again, if I was to draw the aluminium, it would be Al3 plus, and it would be F -1. Now, of course, if we add these up, +3 and a -1, we still have an extra 2 pluses. So how can we combine these two things together so that we'll have a neutral compound? Well, the answer is I've got to add in more of the minuses. There's a second one, and there's a third one. So now I've got one aluminium with a 3 plus, and I've got 3 fluorines with -1 each. So add these up now. These have a 3 minus charge altogether, and the aluminium has a +3 charge altogether. So when we add them up, they are neutral. So that gives me the compound like this: aluminium, AlF3, aluminium fluoride, AlF3. So well done. If you got that right, good job. Now, I've got a table just like the one before for you guys to do. There's more practice in it. Now, I'm just going to point out this one. Bonus points for anybody who gets this one right. This one is quite difficult. Okay, so hopefully you'll be all able to do them all up until that last one, and that last one definitely for sure is a little bit more complicated. Okay, so pause the video and try those now. All right, so the first one is, and you should only be watching if you got these done. The first one is MgCl2. Well done if you got that right. The second one is obviously potassium and iodine are the elements. Potassium and iodine, and the formula is Ki. No numbers, just Ki. Next one is calcium and fluorine. The name is calcium fluoride. And the formula is CaF2. Well done if you got that right. If you didn't get any of these right, you need to go back and watch some of it again. Watch the video again, where I was showing you how to do these. Calcium oxide has the elements calcium and oxygen. And the formula is going to be CaO. Well done if you got that right. Next one, lithium nitrogen. So this is going to be called lithium, metal name first, lithium, and the non-metal then and I'm going to end in IDE, so nitride, lithium nitride. And the formula is going to be Li3N. So well done if you got that right, Li3N. If you didn't, you need to go back and watch that last bit again. Potassium sulfide is got the elements potassium and sulfur, and the formula is going to be K2S. Well done if you got that right. Aluminium chlorine is going to be aluminium chloride is the name, aluminium chloride, and the formula is AlCl3. Well done. The last one, and I'm going to show you how to do this for anybody who struggled with it, and really mean bonus points if you got that right, if you got this one right. Okay, I'm going to write down the name here. Aluminium oxide. So the first thing I do is figure out which group they're in. Aluminium is in group 3, oxygen is in group 6, like that. Sorry, that shouldn't say O6, that should say G6, but it keeps doing that, G6, group 6. Okay, write down what type of ions they form. Aluminium form Al3+, ions, and oxygen form, the oxide ion is O2-. Okay, so Al3+ and O2-. Draw them out. We've got Al3+, and we've got O2-. Now these numbers are quite hard to figure out. How are they going to balance each other? Okay, how are we going to get it to be a neutral compound overall? Because 3 and 2, there's no number that really divide into those equally. It's kind of hard to maybe see it. But if we double the number of aluminiums, Al3+, add another one of these, then altogether we have a +6 charge. Now we still have a -2 charge, but we could put in another one, O2-. Now we have a -4. And what about another one, O2-? Now we have a -6 charge. So now they have balanced out. So the correct formula for this one would be Al2O3. So well done, really well done if you got that. If you got that by yourself, real bonus points to you. Okay, so Al2O3 is the correct formula. And obviously the elements in here are aluminium and oxygen. So really, really, really fantastic job. I mean, fantastic job if you've done all of these and got them all right. Okay, if you've got all them right, then well done. Okay, and this one is just like a super hard one. Okay, so it's Al2O3. And because it's a 2 and a 3, it can be sort of difficult to see how to balance them out. But you kind of just play around. I played around with I played around with one side until I got the other side to balance up. This kind of trial and error. But you don't have to do too much. You just add another one of the 3+, and then you see, okay, I need to add 2 more of the 2- to get them to the same number, which is +6 and -6. All right, that's it, guys. You now know how to predict the formulas of the chemical formulas of different ionic substances. So all of these are different ionic substances, and we know that because they all have a metal and a non-metal in them. They're all chemical formulas for ionic substances, and we have found out how to predict what the formula will be when we know what elements are in there. So if we know what elements and what group they belong to, then you can predict the formula, which is something that's really cool. It's a really neat thing to be able to do. And it's really important fundamental of chemistry that you guys can actually go, okay, I'm reacting this with this. It's going to give me this thing at the end. This is the formula of what's going to be produced. Really important skill to be able to do. So well done. That was it, guys. I'll see you in the next video.